Light a match and watch it burn. In a few seconds, the wood turns to ash, heat, and light. Something clearly changed, but nothing disappeared. So what actually happened? A chemical reaction is simply a rearrangement of atoms. Atoms don't vanish. They don't appear from nowhere. They just break old connections and form new ones. Let's go a little deeper. In every chemical reaction, the starting substances are called reactants, and the substances formed are called products. The atoms in the reactants are the same atoms in the products, just connected differently. That's why chemistry follows one unbreakable rule. Matter is conserved. But wait, here's the twist. Because atoms must be conserved, reactions have to be written carefully. That's where chemical equations come in. They're like a recipe written in symbols, showing exactly what reacts and what forms. For example, when hydrogen reacts with oxygen, water forms. But one hydrogen atom isn't enough. The numbers must match on both sides. So equations are balanced, not to look neat, because nature demands it. Here's something even more interesting. A chemical equation doesn't just tell you what reacts. It tells you how much reacts. The numbers in front of formulas show the ratio of particles involved, whether it's atoms, molecules, or ions. That's how scientists know how much fuel to burn, how much medicine to produce, or how much reactant is needed in a reaction. Let's connect this to everyday life. Cooking food, charging a battery, rust forming on iron, digesting food in your body. All of these are chemical reactions, written in different ways, following the same basic rules. Before we wrap up, remember this. A chemical equation is not just a line of symbols. It's a story of atoms, where they start, how they rearrange, and where they end up. And that leads to the next question. If equations tell us what happens, how do we calculate exactly how much of each substance is involved? That's where chemistry becomes numerical and surprisingly logical. That's exactly what we explore next.